Good afternoon and welcome to our webinar, HS2 on Track to Net Zero. I'm Marina Garcia Gomez and I'm a project management graduate recently joined HS2. We're really proud to bring you this webinar in support of Decarbonising Transport Week, the UK's National Awareness Week, which provides a dedicated platform to voice opinions, share advice and information to help us highlight the solutions to deliver the biggest gains in our transition to a low carbon transport network. The carbon emissions challenge that we face have never been clearer. The UK's pledge to bring greenhouse gas emissions to net zero by 2050 is rightly considered amongst the most pressing social and economic issues. However, as it stands, the transport sector is the largest single emitter of greenhouse gases, which places a huge responsibility on those of us in the industry to innovate, challenge, and ultimately set new standards for ourselves. For the UK to tackle climate change while supporting a growing economy and population, we need more zero carbon forms of mass transport, enabling more medium to long distance journeys to be made by electric powered trains and active forms of travel in place of fossil fuels, cars and planes. Britain's new zero carbon high-speed railway, High-Speed 2, will deliver exactly this from its first day of operation, with every single train powered by carbon-free electricity. But let's move on before I delve into the main bulk of the webinar to quickly run you through some housekeeping and what we've got in store for you today. We don't anticipate any technical issues during our event, but should you experience any connectivity issues, for instance, if your feed freezes, wait for about 10 seconds and it will most likely correct itself. If this doesn't happen, use the leave button to exit the event and rejoin using the event link. This slide just shows some of the features of Microsoft Teams in case you're not familiar with it. Along the bottom are the play and pause, volume, and full screen controls. All attendees' microphones are muted. However, you can still participate through the submission of questions via the questions panel on the right-hand side of your screen. If at any point during the conversation you want to ask a question, you can click the Ask a Question button, type in your question, and hit send. This will come straight through to me. I will be keeping an eye on the questions that come through as we go, and then at the end of the session, we will answer as many of them as we have time to get through. Finally, your feedback on today's session event is greatly appreciated. After the session, we will send around a short feedback form, which will only take a couple of minutes. We want to learn more about what you think is important in helping us improve and develop our engagement. Also, I do want to outline that we want to have a really friendly, informative event today. We want to get lots of questions and have a really good discussion, but in all of our interactions, we do ask that people are respectful towards our staff. If you do have any specific issues where perhaps our works are affecting you and you need a direct conversation, please do get in touch with us via our help desk, which is available 24 hours a day, 7 days per week, and we will be happy to help wherever we can. If you want to find out more about our statement on conducting respectful conversations, the statement is on our website. Now on to what we have in store for you today. We'll kick off with our carbon expert, Mark, who will explain why we need HS2 to cut carbon and reach net zero, including how we're pioneering a cleaner way to build and run high-speed railways. Then we'll move on to our senior analyst, Amy, who'll first talk us through what modal shift is and why it matters, before talking about the role HS2 will be playing in getting people out of cars and planes onto trains. Then Amy will move on to look at the prevalence of high-speed rail in Europe and how it's decarbonized the continent's transport system. At the end, we'll have around 10 to 15 minutes to put your questions to our panel. Now, I'll pass you over to Mark to kick us off.
Thanks, Marina, and good afternoon, everyone. So I'm going to start with an introduction to HS2. So what is HS2? Well, HS2 is Britain's new high-speed railway, and it's being built now. HS2 trains will link 4 of the UK's 5 largest economic regions: the Scottish Central Belt, the North West, West Midlands and the South East. And HS2 will integrate with new lines and upgrades across Britain's rail system to deliver faster travel to many towns and cities across Britain, not directly on the HS2 route, so including Liverpool, Sheffield, Nottingham and Derby. The government is planning over 260 miles of new high-speed line across the country, with HS2 building 230 miles, and 170 miles of new high-speed line is already under construction between Crewe and London. We're building HS2 to the highest standards, using world-class engineering to protect the countryside, protect local communities and to cut carbon. And this is a huge undertaking. It's Britain's first new intercity railway north of London in 100 years and Europe's largest infrastructure project. To achieve the same level of economic and environmental benefits seen from high-speed rail in mainland Europe and Asia, Britain needs a nationwide high-speed rail network. HS2 will be exactly this. So Britain's high-speed rail network, helping to address three key problems facing the nation. And those are capacity, carbon, and connectivity. So in terms of capacity, UK rail demand has more than doubled in the last 20 years and is forecast to keep growing, with significant pressure on key north-south routes. Further upgrades to current lines would cause significant disruption for passengers and line-side communities and would deliver a fraction of the capacity as a new railway line. So building HS2 unlocks a massive amount of space on the existing railway. It does that by placing high-speed passenger services on their own pair of tracks. HS2 adds hundreds of thousands of seats onto the network every day, and by taking long-distance services off the existing rail network, frees up space for freight services, as well as local and regional passenger trains. The HS2 is also about connectivity. So HS2 has the potential to change the economic geography of the country and be a catalyst for growth. By bringing Britain closer together, there can be more investment in the Midlands and the North, opening up leisure and job opportunities for millions of people. But importantly, HS2 is also about carbon. So transport is the UK's largest emitter of carbon. Transport accounted for 27% of the UK's total emissions in 2019. So decarbonising transport is critical to achieve net zero. And for the UK to tackle climate change while supporting a growing economy and population, we need more zero carbon forms of transport, and HS2 will deliver that. So HS2 will offer zero carbon travel as a clean alternative to long distance car journeys and flights, and help the UK to tackle climate change and improve air quality. HS2 will be a critical part of a net zero carbon transport system, so it will deliver zero carbon journeys to hundreds of thousands of people every day, and it will contribute to the decarbonisation of the wider transport sector through modal shift of journeys from road and air to rail, which Amy will explain in more detail later on. So to effectively decarbonise, we need to understand our carbon impact. And at HS2, we're taking a whole life carbon approach to manage and reduce carbon emissions. That means we're accounting for emissions throughout the project lifecycle, regardless of where in the value chain they occur. And this slide presents what the whole life carbon footprint at phase 1 of HS2 would look like if we were simply to adopt current UK industry practice. So this includes construction and 120 years of operation of the HS2 network between Birmingham and London. So you can see that about 3/4 of the whole life carbon emissions are associated with the construction, and the remaining quarter associated with operations, the majority of which is associated with energy consumed to operate HS2 trains, stations, depots and infrastructure. Today we're focusing on HS2, the operational railway, so majoring on the last two boxes about maintenance, replacement and operational energy. However, it's important to recognise that decarbonising transport isn't just about operational and user carbon. We also need to consider how to decarbonise transport infrastructure, and that's why at HS2 we consider whole life carbon emissions. And then it's also worth recognising that decarbonising transport is part of the solution to decarbonising transport infrastructure. So you can see that 11% of the whole life carbon impact of phase 1 of HS2 is associated with the transport of construction materials to site, but there's also transport associated with the extraction and manufacturing of those materials. And similarly, the construction and installation stage includes movements of earth within construction sites and transport of construction, demolition and excavation waste from sites. So decarbonising transport is really important for the transport sector, but also for total UK carbon emissions more generally. So HS2, we're doing more than carbon accounting. Yes, it's important that we understand our carbon impact, but we need to take action to effectively manage and minimise carbon emissions. And that's why we're implementing carbon management best practice. So this slide summarises the key components of our carbon management system, which is accredited to the industry best practice standard for carbon management, which is called PAS 2080. We were the first transport client to achieve the accreditation, And the accreditation recognises that we have the right processes and capabilities in place to effectively manage carbon emissions to ultimately achieve carbon reduction. So we're applying this best practice now, but we're applying it throughout the project life cycle, including through into the operational railway. So we'll continue to apply best practice in the operational phase as well. So the rolling stock, or the HS2 trains, are a good example of activity taking place now to decarbonise operations of HS2. So the design, manufacture, assembly and testing of the new trains, that's been shared by Hitachi Rail and Alstom, and the trains have been designed now. The trains are fully electric, so that's a lower carbon form of power compared to, for example, diesel. But the trains are also highly energy efficient. So we have various features, including regenerative braking, so that recovers the majority of the energy from braking. That's good from a direct energy efficiency perspective, but it also limits heat input to tunnels, which would otherwise require additional energy to ventilate and cool. We have a connected driver advisory system, so that provides advice to the train captain when driving manually on the classic rail network, and that supports energy efficient driving. And then a series of requirements such as maximum cross-section for the trains to meet aerodynamic requirements to drive reductions in energy consumption. And then they'll also be fitted with an energy metering system, so equipment and software to monitor the energy usage of the train by the train operator to enable energy management. Our stations and depots, they'll also be highly energy efficient, so we're applying the energy hierarchy as we design and build those stations and depots. So that includes adopting passive design solutions such as natural ventilation and natural lighting. They've been optimized to reduce energy demand in the first instance. We're then specifying energy efficient systems, so low energy lighting and heating to reduce energy consumption. And then all of that is being complemented with on-site renewable energy technologies such as solar panels and ground source heat pumps. But beyond that, HS2s and our station and depot designs also encouraging people to choose low and zero carbon modes of travel to get to and from HS2 stations. So the stations will have electric vehicle charging points, and they'll connect with walking, cycling and local public transport, including trams and trains. And we're working collaboratively with local stakeholders to integrate HS2 with their regional travel plans to make HS2 the backbone of Britain's sustainable transport system. We're also targeting BREEAM Excellent for all our stations and depots, which is supporting the delivery of our carbon reduction objectives. Birmingham Interchange Station, as an example, has achieved BREEAM Outstanding at design stage, and that's the first railway station in the world to achieve this rating. The HS2 infrastructure is equally with designing and building with future operational carbon emissions in mind. So we're applying circular economy principles to reduce the amount of material that is used now and in the future. And our circular economy principles are to keep resources in use for as long as possible, recover and regenerate resources at the end of each use, and keep resources at their highest quality and value at all time. So part of this is by designing for low maintenance, and the adoption of the slab track system over a ballast track system is an example of this. We're also designing for deconstruction, which supports our aim to recover materials at the end of each use phase. And importantly, we're also future-proofing the infrastructure, so designing with a changing climate in mind, and the infrastructure has been designed to enable speeds of up to 400 kilometers per hour, though the maximum speed in opening will be 360 kilometers per hour. And that's to allow it to accommodate future improvements in technology without fundamentally having to redesign or re-engineer the infrastructure. But we want and we need to go further. And that's why at the start of last year, we launched our net zero carbon plan. So the plan explains the work that we've undertaken to date and what we're doing now. And then it maps the progress that we'll make in the years ahead on our journey to achieving net zero carbon emissions in 2035. So the plan lays out actions, including to become a net zero carbon business by 2025, delivering zero carbon travel from day one of operation, and ultimately achieving net zero carbon construction and operation from 2035. And what we mean by that is that we'll reduce emissions as far as possible, and from 2035 we'll offset residual carbon emissions that we can't eliminate as we build maintain and operate HS2. So we've set out some stepping stones on that journey. We plan to work towards net zero by eliminating diesel on all our construction sites by 2029, specifying and purchasing concrete and steel with half the production carbon emissions of 21 levels by 2030, and using 100% zero carbon electricity to power our trains, stations, depots and infrastructure. The plan also looks at the ways we'll influence the wider construction and manufacturing industries to create a cleaner, greener future. And zero carbon travel on HS2 and modal shift is also a key part of how we'll deliver against our plan. So I'll now hand over to Amy, who will talk about this further.
Thanks, Mark. So as Mark mentioned, the transport sector is one of the UK's largest greenhouse gas emitters. In fact, in 2019, UK domestic emissions totaled 455 million tonnes of carbon, with transport being the single largest contributor at 27%. While other industries such as the power sector have taken substantial steps in decarbonising over recent years, transport has been unable to make the same level of progress and has remained broadly level in overall national emissions. In its Transport Decarbonisation Plan, or the TDP, the Department for Transport has outlined that the electrification of road vehicles and the increased efficiency of domestic air travel alone will not be enough to achieve the government's target of net zero by 2050. To achieve its emission reduction targets, the UK must work to decarbonise the movement of people and goods. And in order to do this, the TDP places a heavy emphasis on modal shift. Modal shift refers to the shifting of passengers from one mode of transport to another. Beneficial modal shift comes about when passengers are moving from high carbon to low or zero carbon modes. For example, this might mean that passengers changing the way they travel, moving from air and road onto rail. Achieving modal shift requires behavioural changes in consumers. So imagine you're planning a trip from London to Edinburgh for the weekend. What sorts of factors come into play when you're making that decision on what mode of transport to take to get there? I'd imagine one of the first things that most people would think about would be journey time, so how quickly you're able to reach the destination. This may also include considerations of the journey time to reach the station or the airport on either end of your journey. You're likely to also think about the relative costs of travelling via car versus plane and train, so whether that be the ticket price or maybe the fuel cost for the car. Other factors may also come into play, such as comfort, so the car might be private, whereas on the train or the plane, maybe you can relax, catch up on some work, there might be Wi-Fi, you have the option of ordering food and drink. Then there are other considerations such as frequency, reliability, and many more. And every time a consumer makes a decision on how they travel, they consciously or subconsciously weigh up these factors, amongst others. Encouraging people to move from high carbon to low or zero carbon modes may initially seem challenging, but by making zero carbon options more attractive, people can be encouraged to change the way that they travel. And this is where HS2 comes in. HS2 will deliver beneficial modal shift in the UK, but how? Well, this links back to the 3 C's that Mark mentioned: connectivity, capacity, and carbon. Connectivity. HS2 will compete on key domestic air corridors and road networks between the UK's major cities. The improved connectivity that HS2 will deliver by cutting journey times will make it an attractive alternative to travelling by air or by road. Capacity. HS2 will have the capacity to accommodate modal shift on a large scale. By adding hundreds of thousands of seats onto the rail network every day, HS2 unlocks capacity on the existing rail network, enabling people to change the way that they travel. By taking long-distance services off the congested West Coast Main Line, HS2 will free up seats for more commuter services into Manchester Piccadilly. It will treble the number of seats available per hour between Birmingham and Manchester, from 450 to 1,500 seats per hour, and more than double capacity between Manchester and London, from 1,800 to 3,900 seats in each direction. And carbon. HS2 will deliver beneficial modal shift by enabling people to move from high carbon modes to zero carbon high-speed rail. The table that you can see on the screen shows the grams of carbon dioxide emitted per passenger kilometre for various modes. Unsurprisingly, domestic air travel is by far the greatest emitter at 170 grams per passenger kilometre. Car travel follows air at 67 grams per passenger kilometre and conventional intercity rail at 22 grams. HS2, on the other hand, is committed to using 100% zero carbon electricity to power our trains, stations, depots and infrastructure, so it has a 0 grams per passenger kilometre impact. And in addition to improvements in connectivity and capacity, HS2 is committed to the customer experience. This will make HS2 a really attractive option versus other modes. Internationally, there's plenty of evidence of modal shifting when high-speed rail services have been introduced. High-speed rail has a proven track record in attracting those who would otherwise choose to travel by car or fly. This chart shows how the introduction of high-speed rail services impacted passenger volumes on various air routes around the world. This shows passenger volume reductions of up to 80% on competing air routes. The Madrid-Barcelona line, which has the smallest impact on air demand of the example shown here, still reduces aviation passenger kilometres by over 20%. And focusing on France, there's evidence that high-speed rail has attracted travellers who would otherwise use private cars or domestic aviation services. The TGV is France's intercity high-speed rail service. The first service came into operation 40 years ago between Paris and Lyon. Since then, a network centred on Paris has expanded to connect major cities across France and in neighbouring countries. The pie chart shows the origin of passenger demand observed upon the opening of the Mediterranean branch of the high-speed line. Over half of the total observed demand was derived from modal shift from air and car. 40% of observed passenger demand was derived from air and nearly 30% from car. The remaining 33% of observed demand was newly generated demand brought about from the opening of the line. This research shows that by reducing journey times, the TGV was able to influence the modes by which people decide to travel. The Eurostar provides another really clear example of modal shift from air to rail following the introduction of high speed. The red line on the chart shows passenger demand for air between London and Paris. The blue line shows the demand for high-speed rail following the introduction of Eurostar in 1994. It can be seen that as passenger demand for Eurostar grows, there is a reduction in London-Paris air passengers. And this is set against a backdrop of increasing demand for UK-France air travel in general over the period shown. Between the introduction of Eurostar and 2007, air demand between Paris and London is shown to have halved, from 4 million passengers per annum in 1994 to just over 2 million passengers per annum by 2007. So there's plenty of evidence of the positive impact of high-speed rail internationally, but what impact do we think HS2 will have? HS2 Limited produce estimates of the predicted modal shift impacts of the opening of the HS2 scheme. These estimates are produced using our transport model, the Planet Framework Model, or PFM. In 2050, it is estimated that there will be 770,000 fewer passenger trips by plane as a result of HS2. As highlighted earlier, trips taken by plane have a large carbon footprint, as planes emit considerably more CO2 emissions per passenger kilometre than other modes. By moving passengers from planes, HS2 is estimated to reduce aviation emissions by 50,000 tonnes of carbon dioxide in the year 2050. The largest reduction in air trips is between London and Scotland, which is a key domestic aviation route that HS2 competes against, with 200,000 fewer trips in the year 2050. It is estimated that HS2 will lead to 1.8 million fewer passenger trips by car in 2050. This reduction in passenger trips is estimated to reduce road emissions by 15,000 tonnes of carbon dioxide. In comparison to international evidence, we believe these estimates to be on the conservative side, but in total, this means HS2 will reduce CO2 emissions by 65,000 tonnes in the year 2050. So to summarise, HS2 has a huge role to play in the decarbonisation of the transport sector, Britain's largest emitter, by delivering zero carbon intercity travel from day one of operation, improving capacity and connectivity, enabling and encouraging people to change the way that they travel, cutting the number of carbon-intensive domestic flights and car journeys in the UK in the same way that high-speed rail has done so across Europe. And through seamless integration with local and regional transport networks, we will play a really key role in the decarbonisation of the UK transport sector. Thanks for listening, and I will now pass you back on to Marina.
So just a quick reminder about how to post questions. On the right of your screen, you should see a box, and this is the area where you can post your questions, and you should see any published responses. We'd like to welcome questions from the audience for Amy, Mark, or myself. In the meantime, I've got a couple questions for you both. Amy, what implications does the increased uptake of electric vehicles have for HS2's modal shift impacts on car journeys?
Thanks, Marina. Yeah, so of course, the quicker the transition to electric vehicles, the less benefit that HS2 can kind of claim in terms of that modal shift from road over to high-speed rail. However, of course, we are really fully supportive of the transition to electric vehicles. They're obviously a really key part of decarbonisation within the UK and will support us in reaching net zero by 2050. When we model the emissions impact of modal shift from road, we do take the transition to electric vehicles into account by factoring in fleet mixes between diesel, petrol and electric vehicles over time. I think it's good to note that we sort of focused on modal shift from aviation today, and that's because, as I sort of presented earlier, domestic aviation is significantly more carbon intensive than car travel. So the more people we can obviously get off of planes and onto high-speed rail, the better. Thanks.
Thank you. And Mark, what is HS2 doing to decarbonise transport emissions associated with the construction of HS2?
Thanks, Marina. Yeah, so first and foremost, we're optimising the efficiency of our construction logistics, so to reduce movements and transport things in the most efficient way. An example of that is our use of conveyor belts to transport excavated material. So we have a 1.7 mile long network of conveyors operating in West London, which will move over 5 million tonnes of spoil excavated from the construction of HS2. So the conveyors, they'll remove the need for about 1 million lorry movements from roads in West London, reducing traffic congestion and emissions in the local area. For longer distances, we're using freight trains to move material for construction. So we're doing this as an example in Buckinghamshire, where we have about 1,800 freight trains that will take 300,000 lorry movements off local roads. Again, that's reducing local community impacts, but also achieving carbon reduction. And delivering this material by rail instead of heavy good vehicles is expected to save approximately 28,000 tonnes of carbon, and that's the equivalent of 126 million miles driven by an average petrol car. But we're also doing a lot to directly decarbonise transport. So our net zero carbon plan sets out a target to reduce the carbon intensity of HGV movements by 11% by 2027 compared to 2020. We've set emission requirements and targets for the engines of the vehicles that our contractors are using in their heavy goods vehicles, and also for vans and cars. So we're requiring the cleanest standard for heavy vehicles, Euro 6 currently. And we have a target for 100% of cars and 75% of vans to be ultra low emission vehicles. And then more generally, we've also got an extensive innovation programme aimed at supporting the transition from diesel to zero emissions by developing and trialling alternative technologies to inform future solutions. So we've been working with the Manufacturing Technology Centre to investigate the use of hydrogen as an alternative fuel, starting with a dual fuel system, and also looking at what needs to happen to stimulate supply and demand for hydrogen. And as part of that activity, we've got 3 HGVs that have been retrofitted to demonstrate the dual fuel technology in construction.
Thank you. So we've got a couple questions that have come in throughout your presentations. Amy, you mentioned customer experience being a factor in people choosing to travel on HS2. Can you tell us what that experience will be like on HS2?
Yeah, sure. So yeah, I mentioned on one of my slides that HS2 are putting a lot of thought into the experience that customers will have when they're using the railway. We really want people to enjoy the experience of travelling on HS2, and we also think that this is really important when it comes to achieving modal shift. We want customers to feel stress-free from buying the ticket at the very beginning of that sort of journey, whilst you're still sort of sat at home, right through to reaching that destination. And stations are a key part of that journey, and we really want to get those right. So that includes simple things such as making sure that the stations are clean, safe, easy to navigate around. So we don't want people kind of running around stressed about finding where they should be. We also think it's really key that passengers receive the information that they need when they need it. So maybe that's around what platform they should be at, whereabouts on that platform they should be stood, that kind of thing. We also really want travel to be seamless. So that's why, as Mark sort of mentioned in his presentation earlier, we want to work with local stakeholders, and we are doing that already, to integrate HS2 with their regional travel plans. So that will hopefully enable people to travel really easily and sustainably door to door. The other area that we think is quite key is the rolling stock or trains. So that's another area of focus for us. We want to ensure that the actual journey on the train is as comfortable as possible for passengers. So we're putting a lot of thought into things such as seat design, the catering offer, and again, the way that we'll communicate to passengers whilst they're on board.
Thank you. Will higher capacity lead to more affordable travel? For example, lower ticket prices? This will be hugely important, if not critical factor in sustained modal shift. Amy, would you like to take this one?
Yeah. Yeah, I can give that one a go. So as far as I know, fares policy isn't kind of in place at the moment. However, that's something that the West Coast partner who would take on the sort of operation of the rail network from us would figure out. I mean, I think, as you mentioned, fares policy will be really key in achieving modal shift. That's one of the things that I sort of mentioned earlier when I was talking about the factors that people consider when deciding which mode they take. So of course, I think, yeah, fares policy will definitely be something that we need to try to get right in order to, as one of those factors that sort of plays a massive part in taking people over from aviation and cars.
Thank you. More and more people are working from home. What does this mean for HS2? Will there be less demand for travel?
Hey, yeah, I'm happy to pick that one up as well. Yeah, so of course, if people are working from home more and more as sort of technology changes and as a result of COVID, that is going to have impacts on demand for transport in general. So that's not just something that would affect HS2, but also all modes of transport. Some figures were recently published by the Department for Transport back in July that kind of show that rail passenger numbers are now consistently reaching 90+ % of pre-COVID levels. So that's really promising and kind of suggests that people are keen to get travelling again and aren't being deterred. It's also kind of important to note that HS2 isn't really envisaged as a commuter service. It's more long distance intercity travel. So that's sort of impacted less by movements towards working from home. And at the moment, only a minority of people commute using the West Coast Main Line. So yeah, we don't really see working from home as a sort of major issue.
Thank you. Mark, at what stage of the design do we start considering carbon? In their experience, it's not consistently being assessed as a key factor during optioneering feasibility stage.
Yeah, well, it's really important to consider carbon right from the outset because it's in the earliest design stages where you have the opportunity to build less and build clever. that the biggest potential for carbon reduction is. So at HS2, carbon reduction has been a key consideration in all of our optioneering. So even back in the 2011 appraisal of sustainability, the carbon impact of the scheme, both in terms of the construction, the emissions from operation, but the modal shift benefits, were considered in those appraisals to inform what the proposed scheme looked like. And then for phase one in the 2013 environmental statements, again, we published our carbon assessments to articulate what the likely impact was from a greenhouse gas emissions perspective across the whole life of the scheme, to inform the decision making and the parliamentary process that ultimately led to the consent for phase one. And we've then repeated that exercise through the parliamentary process for phase one and subsequently for phase 2A and phase 2B western leg. So we've been considering carbon throughout the very earliest stages of the optioneering for HS2, and we continue to do regular assessments to make sure that we're driving carbon reduction as we continue to design and build HS2.
Thank you. So we've got another one for you, Mark. How is HS2 able to ensure access to reliable zero carbon electricity throughout the whole design life?
Yeah, so the net zero carbon plan sets out our aim to power HS2 on zero carbon electricity. Part of there's various approaches here, but part of operating is what we can do for ourselves. So I talked about the adoption of renewable energy at our stations and depots, so solar panels and the like, to ensure that our stations and depots are achieving the nearly zero energy status that we want them to. But then more generally, the traction energy, which is the really big part of the energy that's consumed to power HS2, that's going to come from the national grid. Our contracting procurement strategy for that is been defined currently, and over the last few years we've been working on that and engaging with the suppliers and the generators to understand capacity and capability to respond to this objective. So they've responded very positively, but we're mindful of the lead times that are needed to make sure that there's additional zero carbon electricity generation capacity there, because that's ultimately what we want, is to stimulate additional generation capacity, so that we're not just adding burden by taking the zero carbon electricity capacity that already exists, because that ultimately means there's no net benefit and we're taking it from somewhere else. So the approach is being defined currently. There won't be a single provider. There's likely to be sort of a portfolio approach, including power purchase agreements with generation providers. So it's being defined currently, but we've been working on it for the last few years as well.
That's great. Thank you so much. Amy, aviation is also working towards net zero. Are the estimates using current TCOTE or what they'll be by the time HS2 is running?
Hi, thanks, Marina. Yeah, so the modelling that I presented today is based on assumptions provided by the Department for Transport's Transport Appraisal Guidance, or TAG. So that guidance reflects all agreed policies where policy design's sufficiently kind of advanced to allow robust estimates. So for aviation, that means that, for example, the estimates are based on assumptions around changing fuel efficiencies over time, and a range of assumptions, as I say, that are all sort of determined by that TAG guidance. It's also something we do for the business case when we produce emissions estimates, is also carry out a kind of decarbonisation sensitivity, and that looks at altering some of those assumptions, assuming a greater level of decarbonisation within the de minimum scenario. So that's where we would kind of look at increased an increased level of sort of efficiency in aviation fuels and factors such as that, and include those within that sensitivity.
Thank you. When you carry out your modeling, Amy, what level of decarbonisation do you model in the baseline?
So yeah, this is a very, very similar question to the last one. But yeah, we have our do minimum or baseline, and then we model a scenario with HS2 and then without it in the baseline. So as I said, all of the assumptions for our reference case modelling, our core modelling that goes into the business cases is based on the DFT's transport appraisal guidance, and that's sort of standard, and that's in order so that when different projects across the country are kind of carrying out these appraisals and producing these estimates, that it's all consistent and we're using the same assumptions. So that's sort of the rationale behind doing that. But as I say, we also carry out sensitivities looking at an increased level of decarbonisation within the do minimum. And a good example of somewhere where we sort of flex those assumptions would be road fleet mixes. So, for example, the analysis that I've presented today is based on November 21 tag guidance, which assumes 44% electric vehicles by 2050. In our sensitivity, we increase that to 98% electric vehicles by 2050. So we go a lot more ambitious in terms of the assumptions. So yeah, we have our core reference case scenario, which is transport appraisal guidance, or HM Treasury sort of Green Book compliant, and then we also carry out our own sensitivities around the do minimum.
Okay, thank you. So Mark, we've got a question about will all HS2 stations and depots be powered 100% by renewables, solar, ground source, heat pumps, etc.?
Yeah, so what we're aiming for here is we've set our supply chain and designers and contractors the challenge of achieving what's called nearly zero energy status for our stations and depots. And what that ultimately means is that they need to be designed to be highly energy efficient, and then the little energy that they do need is offset by an equivalent amount of on-site renewable energy generation. So that's specifically in relation to what's called regulated energy. So this is about building integrated systems, so like lighting, heating, ventilation. So that's the first thing, make sure that the stations and depots are really energy efficient, and that they then include on-site renewable energy generation to offset the regulated energy consumption. There's then unregulated energy consumption, which, for example, is emergency lighting, lifts, escalators, tannoys, plug-in equipment. And this is then where the zero carbon electricity procurement strategy is important. So our aim and target there is to procure zero carbon electricity from day one of operation. So that would ultimately be delivering zero carbon energy for the unregulated energy that's not covered by the on-site renewable energy generation. So I guess yes is the short answer.
Thank you. I'm afraid that is all the time that we have for today. Thank you all once again for taking the time to tune in today and for the questions. We've tried our best to answer as many as possible during the time available. If we didn't manage to answer your question today, or if you have any other questions about the wider HS2 program, please contact our help desk. We're available all day, every day. We'd like your feedback on today's session. Please visit the link posted in the announcements or look out for an email from the HS2 following this webinar. Thank you once again for joining and have a great day. Goodbye.